Hi, this is just a short video to get you started on the RARS software for inputting your assembly language programs. So once you have the software on your computer, you just double click on this icon and you would want to start a new file. I'm going to open up the one that I created earlier. So this is the assembly language program for the example that's on Canvas, where we're just inputting 16 bits from the switches, and then we're complementing the bits, and then once the bits have been complemented, we're just outputting them to some LEDs. So you can see it only takes 4 commands. The first thing we have to do is load an immediate, which is just taking this value, which is the address of the switches, and putting it into a register. Okay, we're putting the address of the switches into register X5, and then we're going to use this address to load the data of the switches into register 6, okay, X6. Okay, so this intermediate value again is the address of the switches that we put into register 5, and then we have this load half word unsigned. Okay, remember, a half word is 16 bits, and we just want 16 of the 32 bits of the switches. Okay, so that's why we're using a load half word, and then we're treating the bits as unsigned, so that's why you see the U there. So what this command does is it will add whatever you put to the left of the parentheses to the value that's in that register. So since we loaded the address of the switches into register 5, we're using a 0 offset. We're just adding 0 to that address value since it's already the correct address value. You'll see where this offset comes in handy when we go to output the data to the LEDs coming up shortly. But once we have the data of the switches into register X6, now we can do something with that data. Okay, anytime you perform any process or you want to change any type of data, that data has to be in a register. Okay, so we put the data of the switches into register X6, and then we're going to use this not command or not instruction to complement the bits. And what this not instruction does is it will take what data we have in register X6, it will complement it, and then it puts the results back into the same register. You know, we could put it to another register if we wanted to. Like if I wanted to put it into X7, then I would change this part of the instruction to X7. I'd have not X7 comma X6. Okay, here the register on the left, that's the destination register where the result is put. And on the right, that's the source register where, you know, the change takes place. You know, to see the detailed information on any of these instructions, you would just go to the assembler manual that's on Canvas, and for each instruction it has detailed information on you know, what that instruction is all about. So now that we have our data that came from the switches all complemented, well, now we're just going to output to the LEDs. So this is a store half word command. So we're taking the contents of register 6 X6 and we're going to output it to the LEDs that are at this address. The LEDs are at address 11000020. So you see what we're doing here is we're just adding this 20 hex to what's already in register 5, which is the address of the switches. And if you look at the problem statement, well, the address of the LEDs is 20 hex from the address for the switches. Okay, so that's where the offset can come in handy, because once you have this initial value in the register, you can just change it by just putting an offset instead of repeating these commands. Okay, so now we've got the program typed in. So you would want to save this. I mean, I've already saved it, but you would just want to make sure you save, and then you're going to go ahead and assemble the program, and that's this button right here. And if there's any problems when it goes to assemble, you'll get errors. Okay, any errors would be listed down here in this bottom part of the screen. As you can see here, the operation completed successfully. Now, we have to put in some data for the switches, and notice here it's showing the data segment. Remember how the memory is organized for our RISC adder. You know, we have a data segment, we have a code segment where the program is located, and then we have a memory mapped I/O section where, you know, the input and output data is going to be stored. So that's where we have to go. We have to put in data for the switches. So you come down to this pull down and you want to go to the memory mapped I/O section, and you can see it starts at the address where our switches are at. Okay, this address right here, this hex 11, and then all zeros. So I'm going to put in a value for our switches. And let's see, I'll put in a hex value of all A's. Okay, so each of the 4 bits is a binary 10. 1 0 1 0. Okay, so that's our switch data. Now we can step through, okay, using this button here, we can step through and see how the program is executing. We can see which each instruction does. Now this first instruction, the load immediate instruction, is a sudo command, okay, a sudo instruction, so it's actually made up of these 2 real instructions, the load upper immediate, LUI, and also the add immediate. Again, to see detailed information on these instructions, you can just look at the assembler manual. Okay, but let's see what happens here as we step through the program. So after the first instruction, if you look over to the left here, see it put that immediate value, which is the address of the switches, into register 5, okay, X5. You can see that right here on the right where it's green. Okay, then we'll step it again. And let's see, well, that went, actually the first 2 steps is that first sudo command, because there's 2 instructions in that first sudo command. So now the next step, okay, the next thing that happens is now the data, okay, for the switches, you know, that we had inputted, is put into register X6. Now notice that we inputted all A's, and if you look over here, what was inputted into register X6 is 0, 0, 0, A. And the reason for that is because this is a load half word, so it just took the lower 16 bits. Okay, it just loaded in those lower 16 bits and made the upper 16 bits all 0. Okay, then the next thing that happens is now the not occurs. Okay, so it took that 0, 0, 0, 0, A, and it inverted it, right? It complemented. So now in register X6 is F, 5, 5, 5, 5, and that's because the opposite of 0 is F, right? Because if you have 4 zeros and it changes all the 4 zeros to 1s, well, then you have F in hex. And then the complement of A, right? Remember, A hex is equal to 1, 0, 1, 0. So when you flip that, when you complement it, you get 0, 1, 0, 1. So that's why you see a 5 everywhere there was an A. Okay, and then the last step is now it takes that data that's in register X6 and it outputs it to the address where the LEDs are. And you can see that right here in blue. And again, it was a store half word, so it just outputted the lower 16 bits. Okay, it outputted the 5s, right, the lower 4 bytes here, and you know, the upper half word, or the upper 4 bytes, if you will, is just 0. Okay, so again, the purpose of this video is just to give you a short introduction into this software. Again, it's pretty handy because again, you can just go instruction by instruction and look over here to see if your program is working the way that you intended it to work. So at this point, you should be ready to do the first software assignment. Okay, software number 1.